everybody. I'm Nicole.
I'm Lindsay.
And I'm Sarah, and together we're the co-founders of Whale Tales, a living library of cetacean stories.
And today we have an extra special guest.
So sit back and enjoy as we dive right in.
Today we are very excited to welcome our guest, Nick Freymueller.
Nick is a paleoecologist and a biogeographer who is interested in extinction and species responses to ecological and climate changes throughout Earth's history.
We talked to Nick about not just bowhead whales, though we certainly did talk about bowhead whales, but Nick was really fascinating to talk to because we also just went off on all kinds of incredible tangents about extinction events and species designations and all the things that we typically love to talk about and nerd out about. It was it would be very hard to say what's the nerdiest episode of this podcast
but it was
we've ever
pretty
done.
nerdy.
But it was very nerdy.
It was, delightfully so.
Yeah.
Yeah, and like fossils and all kinds of stuff.
Yeah, it was awesome. So we hope you really enjoy, because we definitely did.
Yes. Okay, so now we are here with Nick Freymueller, who is a bowhead researcher. I think bowhead man that's usually how we
doing my PhD research on bowhead whales, but not necessarily a marine biologist by training. Explicitly, so
excellent. We just had something very similar with our last guest, who we called the blue whale man. So you fit the credentials of whales.
Excellent.
So this is great. If you want to introduce yourself, tell us a little bit about you, and just briefly touch on your research, and then we'll dig into it more after that.
Yeah, so currently researcher of bowhead whales in sort of the final stages of this weird sort of joint PhD that's half based in Denmark at the University of Copenhagen and half based in Australia at the University of Adelaide, located on Ghana country. So I came into this PhD, I'm originally from Alaska, and came into this PhD just because it was on Arctic marine mammals sort of writ large, using some methods that I was really interested in doing. And the overarching theme of my research is understanding all things extinction. How does extinction happen? Why does extinction happen? What happens to ecosystems after a whole bunch of extinctions happen? So most of my background is actually in paleoecology and working with the fossil record, but wanted to do this project and understand how resilient bowhead whales will be to future climate change, just because we have so much fossil data for them in the Arctic. The Arctic's one of the only areas in the world where we have a massive wealth of abundance of fossil records, and there's a lot of historical archives for so many of these marine mammals for really cool geology reasons. So I sort of jumped at the opportunity to do this project, and it ended up being that there was such a diversity and wealth of data on bowhead whales, fossil component, the historical whaling component, and the genetics component. It ended up it made sense to sort of focus my PhD on just this one entire single species at least. But so in the process of between submitting the thesis to both universities and going through all the admin so I can do a final quote unquote defense presentation, as you will. But that's sort of how I got into this research, and I'm, taking it by the horns, have no regrets.
Yeah.
Wow.
By the baleen, I guess.
It's amazing. And I have so many more questions immediately, but my main first one is tell me your thoughts on Jurassic Park.
Yes.
The original one, yes. The progressively subsequent ones, oh God, no. But I watch them because I have to.
It's in your job description.
I mean,
yes.
Yeah. Okay.
Yes. And increasingly fictional.
Fictional.
Yeah.
Although the last one, the one that just came out this month, the mosasaurs did breach exactly like a humpback whale. So I'm pretty sure they just painted a humpback whale, like a mosasaurus, over a humpback whale. So that's technically a great gateway back into paleontology, whale
for marine
biology.
Sure.
Let's go with that.
Let's go with it.
Okay, my first question of many is, when you're talking about the sort of how resilient a species, whether it's bowheads, which you're specializing in for your paper, or just in general, your sort of work in paleobiology, that's a hard thing to say. What do you use to determine that? So like when you're looking at bowheads and how resilient they'll be to climate change specifically, what are the factors you're looking at?
Yeah, so I think you could tackle this from a number of different ways. And so there's a genetics component to this. So if they have very low genetic diversity, if there's some pathogen or there's some part of them that is, say not really, really sensitive to loss of sea ice or loss of food sources or parasite load, if they have very low genetic diversity, then, the whole population could theoretically be implicated. So that's one aspect that we could do it. Whereas if there's a large genetic diversity, maybe there's some pathogen or lack of food source that only affects some part of the population, but other parts of the population that are not as sensitive to that pathogen or can pivot to another food source, they may be able to survive. And that's just that natural process of evolution going through there. So that's the genetics is sort of one aspect that we could focus on. I'd say another one that my area is trying to find where suitable bowhead habitat will be over time. That's sort of one of the big aspects of this recent paper that wrote on this. And we're trying to understand, obviously if there's lots of suitable habitat everywhere, sure, there might be pressures from whaling or other issues, but at least there's theoretically areas where they can live, avoid predation, ideally have some food, forage throughout their main summer foraging period. That's all good. But obviously, if there's no suitable habitat for them, that's obviously a massive risk for them. And so that was one of the sort of the key questions that we wanted to ask with this project, because we know that like many other species of Arctic marine mammals, bowhead whales are pretty ice they're heavily seem to be heavily tied with Arctic sea ice. I mean, they're one of the, I think, 11 existing Arctic marine mammal species that spend the entire year round in the Arctic. And so we know that given future climate projections, sea ice projected to decline massively. And we really wanted to sort of understand how devastating will this be for them? Is this going to cause the loss of all of this critical habitat? And so that's sort of the basic premise of the situation. But the challenge with this is, as good as the research is, as we've gone out, observed them swimming around in the ice for the last, say, 50 years or so, relative to other whale species, there's a whole lot of research done on bowhead whales. But we just don't really have a long-term perspective in terms of how they've responded to climate change, past climate change, and of course, everything that we study them today takes place in the legacy of commercial whaling. So if whaling has changed them in some way that, maybe they might be able to respond to sort of climate change, we just don't see it now. So that was sort of the motivation for trying to get this. And like I mentioned earlier, we have a massive bowhead whale and other Arctic marine mammal fossil record. So I went through and basically collected a bunch of data on over 800 radiocarbon dated bowhead whale fossils, used that, also collected a whole bunch of data from going through these old whaling logbooks, trying to understand where were whalers harpooning whales, throughout the Arctic at what time, and using that with some paleoclimate reconstructions to try and understand, well, how is these sort of suitable habitat patterns changed through time, and how is future projected climate change, how severe is that relative to, what they've experienced in the last, say, 11,700 years, the Holocene, which is what we focused on. So trying to just establish a really long-term ecological baseline is the idea.
Yeah.
So cool.
That's so cool. Can you walk us through, even like, I know that you are mainly focusing on the modeling, but how, I don't think I ever thought about Arctic fossils before. I don't really think about fossils a lot anyway, but how does that work, both in the creation of fossils, but also the finding and the digging up?
Yeah, and this is like one of the first things people ask when I talk to them. I work on Arctic marine mammal fossils. Well, you think, okay, a marine, individual, it dies out somewhere out in the ocean, and then its skeleton, if it survives, goes to the bottom of the ocean. So you would assume that they're way out there. I mean, furthermore, because 10,000 years ago, 20,000 years ago, sea levels in most places were much lower than they are now. So you would assume that a lot of marine mammal fossils are, minimum 100 kilometers plus offshore, potentially. And that's true for most places. But the cool thing is in the Arctic, because it's due to the effect of all of these massive ice sheets. So like the Laurentide ice sheet that blanketed most of Canada throughout the last glacial period, there was a Scandinavian ice sheet. But the Earth's crust is interesting. It's kind of like a trampoline. So if you put this massive load of an ice sheet on there, it physically causes the crust to sink. And so even though, globally sea level, might have fallen 130 meters, just due to all that water now being, accumulated in these ice sheets, if you're actually in the area near these ice sheets, the weight of that all that ice that's, 1 kilometer, maybe 2 kilometers thick, physically sinks the crust maybe 300, 400, 500 meters in some places. And so you actually have areas that are, say, shoreline deposits today. We find shoreline deposits. So they were at sea level 10,000 years ago, and they're at maybe 200 meters elevation in some parts of the Arctic. So because once then you remove that ice, you melt all that ice and it goes elsewhere, again, like a trampoline, the Earth's crust rebounds and it shoots back up and it uplifts all these fossils up, about well above modern sea level today, 60 meters, 100 meters, potentially above sea level. And so that's why the Arctic is this, like, one of the only areas in the world where you have these, massive wealth of marine mammal fossils. And so that was part of the reason I jumped at this opportunity, because it's just such a cool geologic story, but we can actually leverage this to go try and tell some really cool biology stories.
Awesome.
That's crazy. It's especially the trampoline analogy is making me think that they just like popped up, like, hello, here we are.
It's a very slow trampoline, but it's the it's still hundreds to thousands of years, and it's still going on in some places. So northern Canada is still uplifting in response to ice sheets that melted there several thousand years ago. Same in parts of Norway as well today. So, and if Greenland, if the Greenland ice sheet melts, there will be a whole bunch of uplift then there as well. Nothing in our lifetimes. This is several hundred to a few thousand years, but several hundred years of millennium in the future paleontologists may find additional fossils around Greenland that are now submerged and inaccessible.
So the fossil, like the actual fossil that they're digging up, is it preserved because of the ice, or is it formed as in like a normal fossil would, or?
Yeah, it's formed in a normal fossil. You have basically, the first step to being a fossil is die, which all these things had to die.
Yep.
And then ideally they get buried in fairly fine scale sediments that are fairly anoxic. So there's much less microbial breakdown. Obviously all the organic matter rots away, or most of the organic matter in the flesh and the blubber and the baleen, most of that rots away. But then you still have the bones, and from the bones you have collagen that's preserved in the bones that you can extract and you can radiocarbon date the collagen. There's often still ancient DNA preserved in a lot of these.
Nice.
In a lot of these fossils.
It is like Jurassic Park.
Just gonna say that.
And so one of the main group I'm working with in Copenhagen, a lot of their research is ancient DNA of Arctic marine mammals writ large, just because we have this massive, cool data sets that we can work with, and we can tell a whole bunch of interesting stories that for almost any other whale species would be lost to time at the bottom of the ocean.
And ancient marine mammal park is only going to have visitors of us. Like, it'll be much less people will come to it than the dinosaur park, but we'll be there.
Yes.
Oh man, that's really cool.
So cool. So I don't know if I'm jumping the bowhead whale or not, but what, if you can, what are the results of these models that you've been looking at?
I can talk
are
about this
bowheads
publicly.
going to be okay?
Yeah, so because our paper's published, so I can go into those results at least. So what we found is that bowhead whales, at least over the past nearly 12,000 years, we found that they're consistently existing in during the summer over the past 11,700 years. Most of our fossils are summer, which is inferred to be summer strandings in the ice. So that's why we modeled summer habitat as well. Most of their summer habitat has been in these areas where you have sea ice that's between about 15 to 30% sea ice cover. And that's been pretty consistent over the last, say, almost 12,000 years. And that's really cool because there's some in different parts of the current bowhead whale range across their 4 different management populations that are often termed stocks, like fisheries are. There's some differentiation between how much ice each of the different population of whales is existing in, but we don't really know if this is a long-term process, if this is just due to recent climate change in the past 30, 40 years, not really sure. So what we've shown is that pretty consistently across their range, they've been in these areas with about 15 to 30% sort of this marginal open ice area. And that sort of tracks with, especially in the Atlantic populations in western and eastern sides of Greenland. That seems to be where we find them today. And so that's been pretty consistent, over almost 12,000 years. So that was really interesting and good to sort of quality check our analyses. But what this means for future is obviously because sea ice is projected to massively decline in response to warming, we project that their suitable habitat is likely to massively decline as well, and potentially as much as over 90% in some areas. So obviously, when we got back to what we mentioned earlier, if the suitable habitat goes for them, goodbye bowheads potentially. So that's one of the sort of massive risks of our what we sort of project. And then there's, we've gotten a little bit of pushback because we're only modeling just what the environmental conditions, what the sea ice is, what the temperature looks like. We're not actually, and where we know they like to stay on these shallow areas along the continental shelf. It's sort of a proxy for where the upwelling zones are that, give all the nutrients that enable all the primary productivity, sort of their food source. So we didn't actually model the food source directly. And so, because it's really hard to do over 12,000 years. I mean, the big onus of our paper was just saying, just from a abiotic or purely climate perspective, where have they been existing? So that's, one direction for future research, but that's the simple gist is that, they've been stable, remarkably stable, even during known climate fluctuations for nearly 12,000 years. But just the rate of warming, future warming, is unlike anything they've experienced, at least in the last 12,000 years of their eco-evolutionary history. And so this obviously might mean that, we might predict that their population sizes, even for the two populations that have recovered from whaling, or at least trended upwards following the cessation of commercial whaling, those populations might be increasingly threatened. We predict, I think, in the Sea of Okhotsk, which is in Russia, sort of west of Kamchatka, north of Japan, that there's suitable habitat there. We project that it's going to be lost entirely by about 2060. And so that population specifically might be the most at risk for future extirpation, because we don't think the whales there ever actually leave the sea, and they don't seem to be able to migrate around Kamchatka further north by Alaska and maybe access better suitable habitat conditions. So that's the broad brushstrokes of what we found in our paper, and I've got a few other projects in the work that are trying to sort of attack this, how resilient they will be from sort of other aspects in terms of how did whaling devastate them, or how has this affected their genetics. But at least from the suitable habitat perspective, it doesn't look that good for them. But so that's which is kind of grim, but it's the reality. So.
Yeah, absolutely. Yeah. So I have two questions regarding this. How old are bowhead whales? Like, is it the 1100, 700 years, or is it like as bowhead as what we know today, or did it go back further and 1100 is all that you were able to go back to? Like, why that number versus what they looked like before that?
Yeah, so we know that I think the species has existed for at least their divergence from their closest. So they're in the right whale family. And this is part of the challenge of understanding this, is because so many of these species have been devastated by whaling. Their genetic diversity is lower, and it can be sort of hard to tell their full evolutionary history. That's one of the benefits of what these ancient DNA methods do, because they allow us to see what they were like prior to whaling. But at least they've existed as a species probably for a few million years.
Okay.
So they seem remarkably consistent throughout that. We chose sort of 11,700 years as our cutoff, just because it's where most of our bowhead whale fossils exist for. There are some Pleistocene age fossils, but they're much fewer in number. And we're also, some of the paleoclimate data we were looking at, it makes good predictions for the Holocene that we, know from comparing with other quality control, but we weren't sort of convinced that it was as useful much further back, 40,000 years ago throughout into the Pleistocene. So we wanted to focus on areas where we had really good confidence that the data we would be working with was robust, it was solid. But that's at least sort of a timeline question. What was the other question that you had touched on?
Yeah, I was just going to ask, like, with this research and then with the access to the whaling logs, do you know what the population numbers were? Like, obviously the last 100 to more years have been decimated by the whaling, but do we have any idea what the population numbers were looking like when you were saying that they've been stable this entire time? They've been growing, they've been in the same kind of range? Yeah.
So it's a good question. We know, and this has been, a lot of people have tried to sort of get at this from we know what the harvest series is. We know roughly how many whales were at least successfully landed by these whaling crews in different parts of the Arctic over time. And so people have basically tried to model this saying, well, we kind of have a rough idea of what their current numbers are. We know what the past harvest series was. So can we try and reconstruct some sort of pre-whaling numbers at least immediately prior to whaling it depends on what population. So the East Greenland population, you have estimates anywhere from about 25,000 to 50,000 whales. For the sort of Eastern Canada, Western Greenland population, it might have been somewhere around 15 to 20,000. That's probably similar for the sort of the Bering, Chukchi, Beaufort population, sort of off the coast of Alaska, Yukon, Northwest Territories, Russian Far East. So somewhere maybe in the 18 to 20,000 range. And then for the Sea of Okhotsk population in Russia, there's very little known about that. Probably at least 6,000, I think, is the one estimate. But a lot of these have sort of fairly wide uncertainty. So this is something that, as I sort of transition into my post-PhD work, some of my postdoctoral work, this is something that we're actually trying to get a much better sense of how many whales were there actually. We know how they were decimated pretty horrifically. And then we know, at least in the Alaskan and Canadian populations, they seem to be recovering quite strongly from whaling, which is good. But in East Greenland and the Sea of Okhotsk, there may be only fewer than 400 individuals there. And so those populations might be, the lower, when species get to low populations and stay there for a long time, that's where just random freak events might have an outsized effect on their numbers. We're talking about Jurassic Park, say maybe not a, end Cretaceous sized asteroid hits somewhere in the Arctic, but a smaller one. And if that hits, somewhere in the East Greenland Sea, maybe that devastates the local population, at least there, but maybe elsewhere they might be okay. But so that's something that people have tried to get that answer on. And what we're trying to do now is, using all this fossil record, these fossil data, using all this ancient DNA, these paleo archives, what can we actually tell about that and get a much more precise estimate? So I think what we model, at least in our paper, was their habitat suitability. That doesn't necessarily translate one-to-one with their actual population size. Even if there's suitable habitat, there might be other processes that maybe cause we know what the maximum, say the carrying capacity, how many whales that environment could sustain. But obviously the actual number of whales for a whole host of other reasons could be lower. And that's something that we're actually trying to get much more precise understanding of moving forward. So at least stay tuned. There will be more bowhead research in the future.
Yay!
Cool. Excellent.
So I have a question that's probably a very obvious one, but because of the nature of what we do, have you ever seen a bowhead with your real eyes?
Unfortunately, no. Unfortunately, no. I don't even know if I've seen the fossils even, because most of my research sounds really cool, but most of my day to day is just spent doing computer modeling at sitting at a desk. I will say I've technically tasted my species. So because I grew up in Alaska, and bowhead whales are such a massive subsistence food source for Inuit peoples across the entire Arctic. I think when I was in probably second grade, I think a kid in my class who had family up on the North Slope, happen, whenever a village up there will hunt a whale, it's, the entire village comes together, they butcher the individual, it's shared amongst the community. It's a really beautiful part of the culture that I, as a person of European ancestry, it's a fascinating and beautiful part of their culture. But I think he had actually brought, a tiny, tiny little bit of bowhead whale down, and it's considered a great, honor to be offered some of that. And it tasted, from memory, and again, this was more than 20 years ago, it tasted like whale. There's no other way to put it. It's very chewy, it's very musty, very rubbery, but it will keep, if you're that far north, there's no soil, there's no farming you can do. You can maybe forage for berries seasonally, but marine mammals are a source of life for sustenance for people there. Absolutely. And so it'll keep you going. So I haven't actually seen one of my study species in person, mainly because half my PhD has been based in Australia, and you don't really see Arctic whales in Australia.
That would be a question I had.
But ironically, I've tasted my species, so I guess half yes to your question.
Well, that wasn't where I was expecting that to go, but I really liked it.
Yeah, me too. Yeah. Have you tried beluga?
I have not tried beluga, no.
Because that's basically the
maybe
same
when I
response.
study them a bit more and am able to make maybe some inroads and partner and co-create knowledge with some indigenous communities. Maybe that might be an option for the future.
Yeah, I think those have been what I've heard from people who've had beluga, is the same kind of response of just the rubbery, dense kind of thing. I'm a vegetarian. I don't know how to describe meat anyway, but anyway.
Yeah. It's chewier than tofu, I'll say that. Much chewier than tofu.
Okay. I can only imagine.
So why Australia, then?
I guess this is just how the PhD was advertised. My advisor here has good collaborations with a whole bunch of people in Denmark, and they, I found this because PhD was advertised on, so one of the scientific societies I'm a part of, the International Biogeography Society, this PhD was advertised, I think, on their Facebook page, and happened to be on using some really cool methods and using some data sources that I have pretty good background in and wanted to develop more. Used it on species that I guess I had tasted but never seen, actually. We weren't sure if it would be on polar bears yet or walrus or some other seals or some of the Arctic whale species, but this is just how the dominoes fell. And it also got me out of the US, which given the current political climate is a bit nice.
Yep.
So
that sounds nice.
I have questions about that society that you just mentioned, the but what was it? The International Biogeography Society, which if you abbreviate that is IBS, but they've now really starting to, say the International Biogeography Society. So it's TIBS, but it's a very cool society that's, biogeography is simply the understanding of why do species live where they are? What are the sort of spatial patterns of this? But a lot of aspect of this is, clearly over ecological and evolutionary time, these sort of long times, how do species respond to climate change? And so that's stuff that has been a forefront of a lot of my research over the last decade or so. And so that's, and I was, very surprised, like, how do you do a PhD that's split not only between two universities, but two continents as well? And that's it. But day to day, you just live and work in one country. Yep. A year later, you move and do the rest of your PhD in another country. Like, that's...
Yeah, but still, that's just at a temperature range. That's a pretty drastic change year to year.
Yeah, it's. I grew up in Alaska originally, and so the cold doesn't bother me. No. And even when I was in Copenhagen, the Danes were freaked out that I was wearing like shorts in 5 degrees C weather. Yeah. What's wrong with you? But coming Australian summers, I've done hot before, but
that's another level.
Yeah,
it hit 44, 45 Celsius here this past summer, and so I was struggling a little bit. Being from Alaska, anything above like 25 is hot, and anything over 30 is I'm struggle busing hard.
I just have to thank you, despite being from Alaska, for your knowledge and seemingly like just ease with Celsius. That was very nice. Like, wait, he's from Alaska. Do I need to? No, that's what that would have been. Yep, great. Yep.
Well, negative. I'm used to negative 40 in growing up in Fairbanks, and negative 40 is where Celsius equals Fahrenheit. So
correct.
There's no conversion necessary at this point.
Yep. There you go.
It's because it's too cold to do the math. That's why they stopped it there. Okay. Does anybody have any other questions? Or we can move on to nerding out about bowheads?
I feel like I have a gazillion more questions, but probably the podcast is good to move on.
I'm happy to answer more questions.
Nick, you're fascinating.
There's cool bowhead stuff.
Your work is fascinating. Nick.
Hello. I haven't left. I'm still here. I'm
so glad. All right. So Nick, thank you so much for sharing what you have been researching. And I think all of us can say that we hope very sincerely that you get to lay your actual eyes on a live bowhead at some point in time. But in the meantime, why don't you help us educate ourselves and our listeners about bowheads in general and what we should know about them out there doing their thing?
So I think they're some of the longest lived cetaceans of any cetacean. I think some of the oldest individuals can get easily over 200 years old. So And because they're an Arctic specialist, they're part of the reason they're almost called bowheads because they have like the largest head to body size ratio of just about any cetacean. I think in the adults, they're just the size of their head is almost 50% the length of their whole body. They're basically just like a giant head with a little bit of, the rest of stomach and everything, but they're kind of short and stocky whales.
Bobblehead.
And so that's, it makes sense in the Arctic, the more you can inhale, the more food you can inhale, and the minimal other parts of your body you have to keep warm. That's obviously really good energy from an energetic perspective. So it's also part of the reason why they were so heavily targeted by whaling, just because for a given length of the individual, they have produce the most blubber, the largest baleen. They were also relatively slow swimming and behaviorally quite docile. And so that's ironically part of the reasons why European and later North American whalers just absolutely devastated them.
Yeah, well, like you said, they're evolved from right whales, so right whales, and then just kind of like plussed to get into the extra great for whaling.
Exactly, yeah. I mean, I think bowheads were one of the first whales that Europeans crossed oceans with the expressed intent of commercially harvesting. I think that it was originally Basque whalers from Spain and France hunting whales off the coast of Newfoundland, early 1530s probably. And then, progressively other parts of the areas, like when Svalbard was discovered by Europeans, whole bunch of whaling happened there. And then later into Canada and more in the Pacific. So over the nearly 400 years of whaling, this species was just absolutely devastated. Jeez. But at least some of the populations now have been able to recover, quite remarkably. So it's actually a really inspiring conservation story.
Yeah, which I feel like that's even more remarkable with their slow lifespan. Like their fecundity must be low. Yeah. So they're just going for it. Go team.
What do we know about their fecundity?
Yeah, so I think sexual maturity is maybe between about 25, maybe 30 years or so, but the individuals keep growing, we think, until they reach about 50 years old. And then they just kind of, we're not sure if they sort of hit a plateau or if they keep just growing, but very, very slowly. But theoretically, they can keep growing and reproducing until they're over 200 years old. There's not really any evidence that there's any sort of post-reproductive males or females in the population.
Whoa.
And some of we're not sure exactly how or why they get up to 200 years old, but we're pretty confident that there are individuals that are older than that. So who knows?
That's insane.
I was not expecting us not to have even like a glimmer of post-reproductive situations. That's crazy.
And part of that may be just because once you get to that age, there's so few individuals, period. Just due to whaling only ended, a little over a century ago for these species. Only in the 1910s. It was one of the only species of whale where sort of the hunt was abandoned due to economic reasons, as opposed to international agreements on, say, whaling moratoria. Like the right whale family, I think, got formal protection in the 1930s, I think. But that's 20 years after people already decided that, these things, bowheads were not economic enough to go send out boats for. And
I guess that makes sense.
Many ships came back to port completely empty-handed, and so that's also when a lot of whaling pivoted to Antarctica. And it was already going on before, but it's when people focus much more exclusively on Antarctica at that point. So, and that's part of the reason why, we know with so many other whale species who still remain low numbers today due to whaling, and some of them are still being commercially harvested as well. Since bowheads were one of the first species to go through that whole bottleneck, it's kind of, they might be like a sentinel species or sort of reflect what other species may respond, in the future. Given
coming back.
There's these massive lag effects where the worst effects of whaling may not come into effect until, generations, whale generations, more than human generations after whaling ended. So,
wow.
I hadn't thought about that.
No, I'm still stuck on the reproducing at 200. That's
we're not sure. We're not sure if they actually do reproduce. Then we do at least know that there are individuals, maybe 200, potentially up to 250 years old, but that there's no cap on how many, on the age at least. So
there's no post-reproduction life really in other baleen whales that we know of, so it would make sense, but it's still wild. I'm just like, they just found a fifth generation humpback calf in the great grandmother, so enough greats anyway, is still alive. So just thinking about that and just like doing that work on bowheads would be insane. We already have trouble with matrilines and stuff with orcas and humpbacks, but when you add in being 200 years old, like who knows what's going to go on in that family tree.
Yeah. I mean, so yes, it's potential that some of the, in the Pacific, because whaling didn't really start there until about the 1840s. So there's conceivably whales alive today that witnessed the onset, the entire devastation of whaling, and the recovery if those individuals weren't killed. Yeah. So it's theoretically possible that you have individuals that are that old, that they saw the entire whaling period start to finish and a century of recovery. So it's remarkable.
That's crazy.
Wow.
Goodness.
That's wild to think about. Yeah. I guess this kind of ties in a little bit to what I was sort of thinking about when you were talking about their sort of modeling and recovery. But in terms of, like, do they have any strong interaction with other whale species in terms of competition or predation, things like that, that would, if nowadays compared to thousands of years ago, as you're modeling, would there be fewer of, say, some other species that might impact the recovery? But this, I guess, also sort of ties into like their current life history or ecosystem.
So we do know that the only real predation threat is occasionally from orcas. Orcas can and have killed bowhead whale calves in the past. Depending on what part of the Arctic are and who you ask, people have very strong feelings about how important orcas are. So that's obviously. And we weren't really able to include that in our modeling. So when we found that they're, in this 15 to 30% sea ice cover in these types of environments with that amount of sea ice, theoretically more open ocean conditions, less ice, may mean more primary productivity, because now you no longer have ice that's blocking the sunlight, and so you can have theoretically more food sources. But that might also open them up to increased predation from killer whales, because we know killer whales are very, very sensitive to ice conditions. Yeah, it's very, very sensitive to that. And there might be other baleen whales that seasonally migrate up into the Arctic during the ice-free summers. And even if they're not, being physically attacking each other or disrupting each other, they're still potentially consuming the same food resources. So and so it's kind of an indirect competition. And this is still something I don't think we really have that good of an understanding of, because it's hard to understand. I mean, it's hard to even observe a lot of these species. They live in very remote parts of the Arctic that it costs a lot of money to go
Absolutely.
Even just monitor them. So I'm not really sure we have the full picture there. And again, because one of the issues with orcas is were also commercially harvested. So maybe the relationship that they had 200, 300, 400 years ago may not exist now, just because orcas are still at low population sizes. So, and I think it's sort of, I'm hopefully impressing on you that, this is why we need these long-term perspectives. Utilizing information from the fossil record or from these, historical archives from whaling logbooks or whaling stations, because these just give us this wealth of information that we would just not be able to observe today. So
absolutely. Yeah, that's something we talk about a lot. Just thinking about, even like you were just saying, a bowhead whale could have been alive through the entire whaling era, and we don't know anything really about most whales before would hardly anything at all before the whaling era, but let alone in the whaling era. Like, we didn't really start paying attention and 50 years ago tops, when we're like, hey, these guys are kind of cool, let's stop killing them. And so and when you have
seems good.
When you have not even bowheads longevity, but even normal whale longevity is so much longer than 50 years. So it's so hard to know all of this kind of stuff, and all we can do is just sit here and look at them and ask them to tell us things about them. And hopefully we can still
their English skills are lacking.
Bowhead, I'd like to know how old you are.
Yeah, stuff like that. See how that works. Has anyone ever tried that? First you have to go find a bowhead.
It's too cold.
I don't think they speak English, and some form of sign language would be quite hard with the flippers.
Yeah,
so.
probably.
Oh, that's so true.
Very disappointing.
So true. I have a question because you've mentioned a couple of times, Nick, about their populations. Mm-hmm. And one of our favorite things to do on this podcast is talk about populations and speciation and who's an ecotype and who's a subspecies and who's a species.
I have there's other findings we have from a paper that is on the genetics. It's a preprint out now. It hasn't gone through the peer review process, but there is a preprint that we've put out there on this type of question. So
I didn't even know that, but that's even more exciting. What I was going to ask was just sort of, can you give us an overview of what, especially as someone who is living in this research right now, maybe even more so with what you just said than I thought 30 seconds ago, what is the current status of different populations of bowheads in terms of not just, endangered, whatever, but like what are the populations and where are they?
Yep. Yeah, so sort of very quickly ran through this earlier, but yeah, so there's 4 current management units or stocks as they are of bowhead whales. There's the Sea of Okhotsk in Russia, which is maybe had 6,000 plus whales prior to whaling. Now it may only have 300 and shows no signs of uptick. That population very obviously quite endangered. There's the Bering Chukchi Beaufort population off the coast of Alaska, may have had 20,000 whales prior to whaling, and may have actually recovered to quite close to that number, even in 100 years after whaling. It's one of the most remarkable recovery patterns of any whale ever. And so that population, I think, is now individually least concern. Canada, the Eastern Canada, Western Greenland population is the third of these, maybe had 18 to 25,000 whales or so pre-whaling. It's maybe now recovered to 6,000 or 8,000. It's unclear whether it's sort of plateaued at this lower number now, and there's depending on who you ask. But at least it still seems to be showing signs of uptick, at least in recent decades. So they're not completely devastated there. And then the East Greenland, Svalbard, Barents Sea population was probably the largest prior to whaling, but likely was reduced by over 95% from whether it's 25 or 50,000 to there's maybe only a few hundred individuals, 300-400. And it similarly, like Okhotsk, shows very few signs of uptick or recovery pre-whaling. And so that population is obviously sort of one of the more threatened ones, and we're not sure if exactly how, at least opposed to Okhotsk, theoretically they, as the Earth warms, species can sort of track their ideal habitats. They shift further north, and at least unlike Okhotsk, East Greenland bowheads may be able to do that for some amount of time. Again, depending on how fast climate change happens and how their food sources change. So theoretically, they may be able to do that for some amount of time.
Wow.
And I guess in terms of, it sounds like what we're sort of getting into is this sort of differentiation between different populations. So yeah, they're sort of treated as 4 distinct populations. We know that within each of these sort of stock boundaries, the whales will sort of move pretty within, throughout the sort of boundaries that they've defined them. But there's only really been sort of inter-stock connectivity, movement between these stocks observed, I think, once in 2012 in sort of around the Northwest Territories Nunavut border in Canada with the sort of Alaskan and Eastern Canada population, individuals from each of those at least interacting in the same space with one another. Some of our genetic stuff suggests that they're actually much more genetically similar over the last, say, 10,000 years. But there's a lot of this is, sort of hard to determine because we're dealing with species that have been devastated by whaling, and that population bottleneck can really distort a lot of the genetic signals. And again, that's why we need a lot of these sort of ancient DNA, that we can extract out of these fossils. And that gives us a pre-whaling perspective, which is massively useful.
Fascinating.
How do you identify individual bowheads?
So I think very similar to other species of whale, where the tail fluke basically acts kind of like a fingerprint. And so if you can, and there's other sort of diagnostic, I think there's some facial features that are also used, and some whales have been observed, coming back to the same summer foraging sites 30 years later. So this is off the coast of Alaska. So it's very similar techniques than relative to what is used for other species of whale as well. And especially for a lot of the aerial photography that's done of them, you can sometimes see, maybe this one has over a series of a number of years has increased, scarring, maybe from an orca attack or something else. But so people are pretty confident in their ability to at least identify, or there is ability to identify at least the same whale potentially over many, many years.
Before we continue with the rest of the episode, we want to take a moment to tell you about how you can support our podcast and everything we do at Whale Tales.
You can become a patron at patreon.com/whaletales. You can join for $1 a month at the porpoise level, $5 a month at the dolphin level, or $10 a month at the whale level.
And each level comes with a variety of perks, if Patreon tells us that you have joined. We're just going to take a quick moment to apologize to all of our patrons who joined in the last few months. There was a big sort of, I don't know.
Something weird happened. Yep. Something
was going on, and Patreon wasn't notifying us that new patrons had joined, or if patrons switched levels, we weren't being notified about that. So if you've been waiting for the aforementioned perks, like thank you postcards in particular, I am so sorry. We're all so sorry. It is not because we aren't grateful that you are here. We are extremely grateful to you. Thank you for being our patrons. And your postcards will be in the mail on the Canadian Labor Day long weekend.
The very beginning of September.
Yes. So very, very sorry. Very unintentional. But that's just one of the perks. And now that we're aware of the problem, it's no longer a problem. So if you become a patron now, one of the perks that might be included is a thank you postcard from us to you. We also have extended interviews and stories with guests who've been on the pod. You can produce your own Fun Flipper Fact segment of the pod, and we also have 2 extra podcasts for our dolphin and whale level members. For Whale Tales Watches this month, we watched an episode of Little Show that you might have never heard of before, but it was really interesting to visit, called Sequest. And it was just I might watch a whole new show now, or I might not. We had a lot to talk about.
I will say, if Blue Sky is any indication, everyone knows about Sequest. People were very excited.
Oh, excellent.
Thank you so much to all of our patrons, secret and not secret.
Yes, new and old.
New and old, known and not known. You are amazing.
If you aren't able to support us financially, there are still lots of things you can do to help us out. You can leave us a rating or a review on your podcast platform of choice. This will help other people find the podcast, and you can also just tell people in your life, especially if they love cetaceans or science or podcasts. You can tell them about the podcast, and you can tell them just about Whale Tales in general so that they can join in on the excitement.
Yay! This includes if you recently started a new job, like I did, and then you tell your coworkers that you have a podcast, and then they, so many of them have told me they're listening. Aww. So hello, new coworkers. You're wonderful. Aww. Thank you for supporting everything that we do at Whale Tales, and also being awesome cetacean/podcast/science nerds. And I really love working with you. Hooray!
Yay! Adorable.
You can also follow us on social media at whaletales_org. And you can send us your feedback there, or in any of the various ways that you can get a hold of us, because we love feedback and we want to keep making this podcast even better.
Yes, this is a surprise thing that puzzled Sarah and I last week. We got a Spotify comment on episode 9 from 2021 saying that the podcast cut out halfway through, which it did, we discovered. Sarah somehow had the full episode, 33 minutes.
No idea what happened.
Audio track that's been on the internet for 4 years and no one said anything is 19 minutes. It cuts off not even just mid-sentence. It is the middle of Nicole telling the story the night before dolphins. It is.
Oh my gosh.
Yeah.
Oh, no.
I know.
I feel like it must have gotten corrupted or something. There's no way that it was like that for 4 years.
Yeah. So we have found the track, and it should be up by now, by the time you're listening to this. If you want to go back, it is a Christmas episode, but if you're feeling it or really interested, or just save it for Christmas. Anyway, that was brought to our attention by a Spotify comment. So please send in those comments. Tell us about a weird thing that happened 4 years ago that we have no way of knowing about.
We love hearing from you. It
also tell us other things.
Truly makes our day.
Yeah.
So thank you.
Yes.
To everyone for supporting us, whatever that support looks like from you. Thank you.
Well, I don't think I have any more questions about bowhead whales. Sarah?
No, I think that, I mean, obviously there's lots to learn, but I think I'm good to...
Yeah, you can sing.
So now it's time for one of our favorite parts of the podcast. It's time for Fun Flipper Fact. It's time for a Fun Flipper Fact with Nick. There we go. That's today's song. Today we're asking you to share something very important with us, even more important than all of the incredible information you've already shared. We're asking for your very, very favorite fun fact about, doesn't have to be bowheads, it can be about any cetacean under the sun.
I think we've already covered it. I've sold myself quickly, but just what we were talking about earlier is the fact that, like, because these individuals can exceed 200 years in age. I mean, there theoretically are individual bowhead whales out there that saw the beginning cessation and 100 years of recovery from whaling, and that just like blows my mind completely.
Oh,
like
how absolutely.
Like, we don't have, like, what other species on Earth could you say that about that would have that knowledge base just because they witnessed it directly? Like,
Greenland sharks.
It's absolutely insane.
Greenland sharks were there, but they weren't being hunted. They were just like, oh no, this is a thing that's happening.
Yeah, and they're also at like several hundred meters depth as well.
So they probably just heard about it in the news. I don't know.
Paid no attention.
They're too busy being sharks.
Yeah.
But no,
that's very fair.
I can't even like wrap my head around it, just because like we talk about whaling so much being in the past, but it really wasn't. And so then therefore these whales being before whaling and still being here, it's crazy. Crazy. Okay.
That's a really good one.
Yeah,
Thank
I really
you for
like
sharing.
that one.
Yes, agreed.
So, Nick, we know that you unfortunately have not yet seen a bowhead in full alive form, but we would love to hear about a cetacean encounter of a whale or dolphin or porpoise that you have seen that was very memorable to you in your life.
Yeah, so I mean, I guess I'll just pick the most recent one. So I was on vacation back in July and was in far north Queensland and going on a Great Barrier Reef snorkeling tour. Unfortunately, I mean, the reef, is largely bleached, but we ended up seeing a pod of about 9 or so humpback whales that were migrating by. And it's just been such a long time since I've been able to see a whale in person. There's a few southern right whale sightings and sometimes humpbacks down here in Adelaide in South Australia, but just being able to, see them breaching up close. And some of them were doing the whole, I'm sure you're familiar with the bubble net trick where they, where they trap a whole bunch of krill in there in this massive bubble net, and then they just consume everything. And we were able to, we got less than 50 meters from them. Wow. And it was just phenomenal to be able to see that up close. But it's sort of ironic just to sort of juxtapose, like, the whales are recovering quite strongly here in Australia, but it's at the same time as these, coral reefs, which are another like sentinel indicator of climate change that are, there's heavy bleaching. So it's this, double-edged sword almost that just sort of keeps me grounded at least. But it's, it's awe-inspiring and both devastating at the same time.
Yeah. That would have been something really incredible to see.
Yeah, that's
because I was looking for them, and because I spotted them a kilometer or so off, I could see at least the vapor from the breaching at least, and it was like, hey, there's like a bunch of whales over there. Yeah. And so we took an hour and a quarter detour and got 2 free beers out of it. So
nice.
Got to nerd out and tell people about my research.
Yeah.
So,
amazing.
That's like every grad student's dream. We'll nerd out about research for beer.
Yeah. Absolutely. Yeah.
Yes, pretty much. I guess maybe before we start wrapping up, is there anything else that you wanted to share with our audience that we haven't asked you about or haven't covered yet?
Yeah, I think that's sort of the broad brushstrokes now, at least of the research that is published, and I can actually talk about at least. We've got some other work in the pipeline. So I've got a big fossil database that includes bowheads and a whole bunch of other Arctic marine mammal species that's hopefully almost accepted. Got one on the genetics that I sort of mentioned that is a preprint of the bowhead specifically. And so it's not gone through the peer review process yet, but we're confident we put a pretty robust project. And then I'm submitting another paper probably later in August about the sort of whaling aspect of them as well. And then future research trying to get into these questions of well, how many were there pre-whaling really? How has whaling devastated them? Just their abundance numbers, their genetics, how will future climate change devastate them, and really try to give this holistic package. So that's my PhD and future work in a nutshell, but there's, there's still to be more bowhead research to come, at least.
Yeah. And then you got to extract the DNA from the mosquito and make your marine park of extinct animals so we can all come and join.
Yeah, I don't know how, marine mosquito. I'm sure there's, blood-sucking parasites, but that must have been what Jurassic Park used for the mosasaur, I'm guessing, because there's no marine mosquitoes to my knowledge, at least. But.
We just don't ask the question anymore.
That's the only
plot point issue with...
Oh, the only plot hole. That's being very generous. But...
And you're defending soon, too, correct?
It was originally supposed to be early September, but we were due to admin sort of chaos and stuff that's being pushed back to probably late October, early November. So not quite yet a doctor of whales, but hopefully soon.
That's a good title.
That's very cool. Very cool. Well, we always like to leave our audience with maybe a bit of optimism or something that they can do to help, maybe in this case, particularly support bowheads or Arctic whales in general. Do you have any suggestions that you'd like to leave our listeners with?
Yeah, so I think one of the things about bowheads that isn't as big of an issue now, and this is true for lots of other Arctic marine mammal species, but may potentially be in the future, is as the Arctic warms, marine shipping traffic is potentially projected to increase drastically. And we know that the limited amount of marine shipping or military activity is highly disruptive to a lot of these Arctic marine mammal species. And there have been, I think, some talks somewhere about trying to see if we can at least, in some cases, the shipping is going to happen on some level, but can we at least try to route it through areas where, there will be minimal impact to the marine ecosystems here? Because the noise it carries throughout long distances, especially because bowheads, like many other whales, they communicate on often lower frequencies than what we can detect, and that just permeates throughout the water. So a deafening blow from a ship can, it sounds like, you're being surrounded by an air raid siren effectively, just constantly. And that's obviously highly disruptive to them. So I would say I'm not as sort of familiar with exactly the specifics of how marine shipping will work in the future. But for people who are trying to make a difference, there are theoretically conversations that can be had, governments that can be lobbied to at least try and say, okay, can we route these marine shipping routes away from areas that are going to have, that at least we predict will have the few remaining safe havens that will have suitable habitat for whales in the future, that will be maybe critical for their summer foraging or migrating. But that's sort of one area that doesn't get as much discussion in the literature now, just because it hasn't happened yet. It is something that people are thinking about, but I think that's definitely something that people can make a difference to, and pressure, governments to try and actually take this seriously. So that's something that I think everyone can have some aspect of about it. And you don't have to be an expert in paleobiology or ancient DNA to say, whales should be able to exist without, having deafening noises blaring around them in the future.
Yeah, absolutely. That's a really good one. I don't think we've had that yet. So thank you for sharing.
Thank you.
Yeah. Great. New call to action. Yeah, so I think that brings us to the end. This has been absolutely fantastic, Nick. Learned so many things about science and whales and the past. I don't know. But
whale fossils.
Yeah, that I didn't even really think that was a thing that we could do.
Yes. So cool.
Very exciting.
And there's potentially more stuff, different techniques that are coming out that may be applicable to other whales in the future. So I just very brief teaser. There's this sort of burgeoning, emerging field of sedimentary ancient DNA. So because the DNA particles for a lot of these species are negatively charged, they can sometimes bind to just out in the environment. When an individual sort of sloughs off DNA, feces, skin, saliva, all that sort of stuff. And if it's sloughed off constantly in the environment, and in both terrestrial and marine settings, it can sometimes bind to the slightly positively charged clay particles that have a lot of potassium in them. And so that can honestly preserve some of these where species were in the past. And so there's interesting work that's some of my colleagues back in Copenhagen are working on about using sedimentary ancient DNA in the marine setting and trying to find out where all these Arctic marine mammal fossils are, or not even fossils, because there's no body that's been preserved. But if you drill a sediment core and you can sort of sample through the history of that, figure out, well, what has been existing in this area over time, and you can potentially do that far offshore where you're never going to find, finding a body fossil is 1 in a million.
Yeah.
So there's really cool burgeoning fields that I think will be really, really useful. We just need to have a bit more collaboration between the sedimentary, the geologists who are drilling these cores and a lot of us in the sort of biosphere. But
that's crazy. I had because we were starting to hear more and more and more about eDNA, but I never considered that it was also a possibility in like sediment or like historical records.
Yeah.
Oh yeah.
That's really cool.
Delightful.
Yeah.
I love that. Amazing.
Yeah. There's a whole bunch of biases that we're still sort of trying to figure out, like, does the sort of concentration of DNA here, does that relate some way to the, what the local abundance was of species at that time? Mm-hmm. Maybe it's just one individual who just loves that particular area and is consistently sloughing off all the DNA. So there's still some issues that we need to, and challenges that we need to overcome, but there's really cool patterns that others that I work with have been able to find out. So there's, science is always developing.
Yeah.
Yeah. That's great.
That's super awesome. Cool. I'm excited to keep
We just need to not bring the dinosaurs back. But
yes. Correct. And it's been 59 minutes and I haven't yet made a Captain America joke, so I'm going to put it in here right at the end. But you never know what you're going to find in that ice, so keep an eye out and let us know if you track them down.
Yes.
And I think that will leave us. We'll definitely keep an eye out for your future work and share it with everyone, because that's pretty exciting. I can't wait to see what other mysteries you uncover in the Arctic. That's so cool.
Yeah, thanks for having me on board.
Thank you so much.
Thank you so much, Nick.
Thank you.
I think that's it. That's as nerdy as we could possibly nerd.
I don't know.
In the confines of an hour-ish long podcast episode. Yes.
We could put the Jurassic Park theme song on right now and just go for it. We'll probably get a copyright hit, but it would be worth it.
It would be so worth it. But since we know you, our dear listeners, are just as nerdy as we are, we would love to hear your nerdy thoughts on this nerdy episode, or any episode. So please visit our website at whale-tales.org to find links to all of our social media handles so that you can drop us a line.
You can also head to our website to subscribe to the podcast, learn about supporting us and becoming a patron, and check out over 1,500 whale, dolphin, and porpoise stories.
That's whale-tales.org. Tales like the stories, not tales like what's on the end of an animal.
You can find Nick on Blue Sky at Smilodontology. That is SMILODONTOLOGY.
Ooh, nice. Good spelling.
Notes here that he is also with that handle on Twitter, but he doesn't really use it anymore.
Yes. Correct.
Yep. And if you've seen a cetacean, we would love to add your story to our library. You can click the share link on our site, or you can contact us on social media at whaletales_org, or you can even email us a voice memo and tell us all about your incredible cetacean encounter.
Finally, we want to acknowledge that we recorded today's episode on the unceded territories of the Coast Salish peoples and the Musqueam, Squamish, Tsleil-Waututh, Sianu, and Sauk nations. Nick joined us from Adelaide, located on Kaurna country.
Thank you all so much for being here. We hope you have a really great day.
Yay! Yay!